and welcome to a video all about functions. Functions. Also, whenever you write functions, you should capitalise the fun bit of it, just for emphasis. Functions are fun. Okay, so in Thursday's lesson, I talked about lots of different concepts. So there was the concept of domain, codomain, range, one-to-one, one-to-many, many-to-one, many-to-many. What else did I talk about? Difference between a mapping and a function. Yeah, pretty much just that. So I want to go over those concepts again, just in case it didn't quite make sense in the lesson, or it did make sense at the time, but you've forgotten it all since then. And I just want to make sure that it's all really clear for you. So let's use some mathematical examples. So if I have a function which I'm going to call f traditionally, and it takes x and it maps x to 5x minus 3. Okay. So usually the way we would write this is f of x equals 5x minus 3. That's a function. Okay. Now the domain of this function is all of the inputs that you could put in. So all the possible inputs. Now the domain can actually be whatever you decide it to be. So for example, I could say the domain of this function is only the natural numbers, or I could say the domain of this function is all the real numbers. It's up to me to decide, because I'm allowed to restrict the domain however I want. But a suitable domain, I mean the most suitable domain, would be real numbers, because there's no reason for it not to be. I've just realised I should remind you what I mean when I say these things. So, right, natural numbers is written like that. It's called blackboard bold, that's what that's called. So that's natural numbers. The natural numbers are 0, 1, 2, 3, 4, etc. They're the counting numbers. Now, there is some debate over whether 0 is a natural number or not. A lot of people would say that 0 is not a natural number because you cannot naturally observe the number 0. For example, you can look in a field and you can see 12 sheep, so you can naturally observe the number 12, but you can't naturally observe the number 0. I mean, I disagree, because you can look in a field and naturally observe 0 sheep, but some people disagree with me there. 0 was a lot of people just didn't even want to give 0 even a name. Back, this is like thousands of years ago, or hundreds, I guess. Sorry. It was Indians who invented 0, although the name comes from Arabic, I believe something like Zafira, which means empty. Something like that? I don't know Arabic. Okay, so that's natural numbers. Integers is a blackboard bold Z, and that means whole numbers including negatives, so like minus 3, minus 2, minus 1, 0, 1, 2, 3. They're integers. What else have we got? Rational numbers is a Q. Q stands for quotient, and it includes the natural numbers. It includes integers, obviously. And I say obviously because, well, actually, I shouldn't have said obviously. If it includes integers, then it includes natural numbers, because natural numbers are included in integers. That makes sense. And it includes anything that can be written as a fraction. So that involves, or includes, I should say, like recurring decimals, because you can always make those into fractions. To any kind of terminating decimal, because that can always be made into a fraction. There's just some decimals that can't be made fractions, like, for example, square root of 2 or pi, things like this. Okay, and then we have R, which is real numbers, and that's just basically everything. Any number you can think of is a real number. It includes all of the other things too. It includes irrational numbers, rational numbers, integers, natural numbers. All of that is basically everything, including pi and whatever. The only thing it doesn't include are imaginary numbers, but if you don't do further maths, you don't even know about imaginary numbers, and you don't need to know about them right now. If you go to do engineering at university, you will become best friends with imaginary numbers, but don't worry about that yet. Okay. So, as I was saying, a good domain for this function would be R, because you can do 5x minus 3 with any numbers. They don't have to be whole numbers to be able to do 5x minus 3. That's fine. Now the codomain, well, what kind of outputs are we going to get? So codomain is what kind of outputs? Well, I would expect if we put a real number into that, we're probably going to get a real number out of it. So the codomain would be R. And then the range is slightly different from the codomain. So the codomain is what kind of outputs are you going to get? The range is more specific than that. It is like it's all the possible outputs. Because there might be some numbers that aren't possible, which you would include in your codomain, but you wouldn't include in the range because they're not possible. In this case, though, all of R is possible because, well, the easiest way to realise that is by thinking, could I undo this function with any value? Like, could I say 5x minus 3 equals this, 5x minus 3 equals that? Could I say 5x minus 3 equals anything and solve it? And the answer is yeah, you can, that's solvable. So the range could be anything. Okay, is this function one-to-one, one-to-many, many-to-one, or many-to-many? Well, if I list some numbers here, so 1, 2, 3, let's put pi in there as well, let's put 0, and let's put minus 20. Okay, this is just a very restricted domain. And then if I work out some outputs, 5, 2, 10, 7, 15, take away 3 is 12, minus 3, 5 pi minus 3, and minus 103. Okay. I'm pretty convinced that this is one-to-one. Because for every value of x that I put in, I'm only going to get one answer. It's impossible for me to get two. And I don't think it's possible for me to have 5x minus 3 equals something and then get two possible values of x which could make that. So I had 5x minus 3 equals, I don't know, 7. There's no way I'm going to solve that and find two values of x. Okay, so it's going to be one-to-one. Because it's one-to-one, it is definitely a function. If it had been one-to-many, then I wouldn't be allowed to call it a function. Or if it was many-to-many, I wouldn't be allowed to call it a function. Because functions have to be something to one. Okay, let's take another example. Let's call this one g, and let's make it that x is mapped to 1 over x. So you could write this as g of x equals 1 over x. Okay, So let's think of a suitable domain. So what are all the possible inputs for x here? Am I allowed to put anything into this function? Well, I could put 2 in, yeah, and I'd get a half, that's fine. I could put -4 in, that would be fine. I could put pi in there, that would be fine. I could put the square root of 2 in there, that would be fine. So I can put any type of number in there, really. So it's real numbers. I could put any real number in there. Except there's one number I can't put in there. There's one number that is not allowed. Yeah? Have you worked out what that number is? Yeah, it's 0. I'm not allowed to put 0 in here. Because if I put 0 in here, I'm going to get 1 divided by 0, and you're not allowed to do 1 divided by 0. So the domain is all of R, but x is not allowed to be 0. So it's the real numbers, but x is not equal to 0. And you are allowed to just write x is not equal to 0, because when you write that, it's obvious that you mean the real numbers. So yeah, that's our domain. What's the codomain? Well, the codomain is what kinds of outputs. So I'm thinking when you do 1 divided by something, you end up with decimals. Sometimes you get fractions, sometimes you get whole numbers. Basically, the kind of output we're going to get is R. You're just going to get real numbers. But then if I want to think about the range, remember the range is what specifically are all the possible values, because not all of these will be possible. Okay, which ones are not possible? Is it possible to get a negative answer? Yeah, it is. If you put a negative input in, you're going to get a negative output, so that's fine. Is it possible to get pi as an answer? Well, yeah, it is actually. If you put 1 over pi into this, then the output would be 1 over 1 over pi, which is pi. So that's fine. Okay, could we get 0 as an answer? Could 1 divided by x equal 0? Well, let's try it. 1 divided by x equals 0, times both sides by x. Oh, yeah. Nah, it doesn't. Okay, so we can't get 0 as an answer. That's actually the only thing we can't get as an answer. So the range would be anything but, oh wait, I can't write x, but g of x, the output, cannot equal 0. So x is not equal to 0 here, but for the range it's g of x is not equal to 0, because this is output rather than input. Yeah? Okay. Is this 1-to-1 or many-to-1, etc.? Let's see. If I put 1 in there, if I put 2, if I put a half, if I put pi, I'm not allowed 0 anyway. Anything else interesting? Let's just put those numbers in. Oh, let's put a negative in as well. -5. If I put these numbers in, 1 divided by 1 is 1, 1 divided by 2 is a half, 1 divided by half is 2, 1 divided by pi is 1 over pi, and minus a fifth. Yeah, everything's just going to map to one thing, isn't it? I'm pretty convinced that nothing's going to map to more than one thing, and there's not 2 things that are going to map to one thing, so it's 1-to-1, which means it is a function. Okay, let's look at a more interesting one. Let's call it h. So h is going to be the function that takes x and it maps it to x minus 3 squared. How about that? So the way we would normally write this is h of x equals x minus 3 squared. Okay, so what would be a suitable domain for this? What's all the possible inputs? Can we put anything into this? Is that allowed? Yeah, basically it's allowed. We're allowed to take away 3 from any number, there's no rules against that. We're allowed to square any number, there's no rules against that. So the domain can be the whole of R. How about the codomain? What kinds of outputs are we going to get? Are they always going to be whole numbers? No. Are they always going to be rational numbers? No, we could get pi squared, for example, is not rational. What kinds of numbers are we going to get? Basically anything, right? Basically anything. Except, well, maybe I'll make my codomain R. And when I think about the range, what values are actually possible? Well, I can only get positive answers. Because once you square something, it becomes positive. So actually, the things that are possible are only positive real numbers. The way to write positive real numbers would either be to write R plus. That's like kind of the fancy way of doing it. I'm not sure I like R plus though, because I feel like that would exclude 0. Yeah, it's a bit dodgy. What's better is to just say x is greater than or equal to 0. It's basically, it's non-negative. Yeah, when I said positive earlier, I meant non-negative because I want to include 0. 0 is not positive or negative. But yeah. So the range would be only positive and 0. Okay. Now let's think about one-to-one, many-to-one, etc. So if I put some numbers in here, 1, 2, 0, minus 2, pi, a third, I don't know. What would this be? 1 take away 3 is minus 2 squared is 4. I just realised I should probably have thought a bit more carefully about how about I put 5? Yeah, let's put 5 in there. Okay, 2 take away 3 is minus 1 squared is 1. Minus 2 minus 3 is 5 squared is 25. 0 take away 3 is 9. 5 take away 3 is 2. 2 squared is 4. Oh. Interesting. Okay. Pi take away 3 squared is, well, it's pi take away 3 squared, of course. And a third take away 3 is 2 and 2/3, which is 6, is 8/3, so squared is 64/9, something like that. Please don't correct me if that's wrong, because I really don't care. Point is, have you noticed that there were 2 thingies that went to 4? That means this is many inputs go to 1 output. So it is many to 1. So many to 1. And because it's to 1, it is still a function. You are allowed to have many inputs giving you 1 output, but what you're not allowed is many outputs coming from 1 input. In terms of a graph, this is fine because it is it's a graph like this where for each x value there's only 1 y value. But for each y value, there's actually 2 x values, but that's okay, it's allowed. Okay, let's go for I don't want to use I, let's just go back to f. F is going to be a function that maps x squared to x. Okay, I can't write this as f of x equals. There's not really a way of me writing it, so I'll just have to write it like that. Okay, the domain. So what's all the possible inputs of this? What can I put in to as x squared and give me x? Well, as long as I don't mind having decimals and stuff, I could put any number. I could put 5 here. My answer would then be the the square root of 5. Well, and it would also be the negative square root of 5, but that's, yeah, it's fine. But I couldn't put a negative number here, because you can't square root a negative number. So the domain would have to only be positive numbers, and it has to be real. So let me just say x squared. I'm not writing x, I'm writing x squared, because that's what's here. X squared would have to be non-negative. Okay. The codomain. So what kinds of outputs are we going to get? We're going to get positive and negative outputs, and they could be anything really. So the codomain would just be R. And the range. Is there anything that's impossible to get? No, it's not actually, is there? Because anything can be the square root of something. So yeah, that's going to be all of R. Okay, now let's draw some inputs and outputs. So let's just put some values in there. Okay, so if x squared is 9, what's x? Well, it's either 3 or minus 3. If x squared is 4, what's x? Well, it's either 2 or minus 2. Let's put 0 in here as well. 2 is going to be root 2 or minus root 2. Pi is going to be root pi or minus root pi. And 0 is just 0. Okay, because it's not going to be negative 0. Okay, so this has one input giving many outputs. So it's 1 to many. Now don't worry about the fact that 0 does not have many outputs. It only has 1. That's fine. It's not that everything has to have many outputs. It's just that one of them has to. And because one of them does, that means it's 1 to many. Which means it's actually not a function. We could call it a mapping, but we can't call it a function. It's not a function because it is 1 to many. And if I tried to draw it, it would look like that, which means that each value of x has 2 possible values of y, and that is not allowed as a function. As a graph, it's allowed. I mean, you can draw whatever graphs you like, but it's not allowed as a function. Which is why I can't really write it as like f of x equals. If I could write it like that, it would be a function, kind of, but I can't. Okay, so let's just do one more. Let's go back to g. So g is going to be x minus 3 squared over x minus 5. How about that? That seems good. Wait, I've written that completely wrong. G of x equals that. How about that? So g maps x to x minus 3 squared over x minus 5. Right, domain. What should be the domain of this? What's all the possible inputs? Can I put anything into this? What's not allowed to be put into this? Am I allowed to put 3 in here? Yeah, I am. I mean, I'd end up with 0 on the top, but that's fine. But what I'm not allowed to put in here is 5, because if I put 5 into here, the denominator is going to be 0, and if you divide by 0, well, you just can't. You're not allowed. Okay? Every time you divide by 0, God kills a kitten. Okay, apparently, that's what I heard. So we cannot put 5 into there. So the domain is going to be basically anything apart from 5. Codomain. By the way, mathematicians basically never talk about codomain. Like, it's all about the domain and range. And on your exam, you will probably never see codomain. It's probably always just going to say range. but the textbook uses it, so I figured we may as well talk about it. Okay, oops, sorry. Codomain, what would be a sensible output? Yeah, we're going to get... Could we get negatives? We could, couldn't we? The top is always going to be positive, but the bottom could be negative. So codomain is basically anything. Okay, but the range, what values are actually possible? So is there anything that is impossible? Let's think. Could I get 0? Yeah, because 3 take away 3. I could get 0. Could I get 1? Yeah, probably. I mean, this I could probably solve that to equal 1. I don't think there's anything too wrong with that. Could I get... let's think. I can't really think of anything I couldn't get. I mean, maybe I would, if I drew the graph, I'd be able to work it out. So I'm happy to say the range is basically anything. And I don't really... yeah, I can get positives and negatives. Because if that's positive... I mean, that's always positive, but this could be negative, so that's fine. Yeah. Basically, it's all okay. You know what? One way I could work out if something's impossible, I could say, let's call it k. Let's find a value that's impossible. I'm going to times both sides by that. I'm going to expand this out. I'm going to take away that from both sides and take away that, no, add that. Okay, so I've got a quadratic. What's the discriminant of this? B squared b squared minus 4 times a times c. If the discriminant is negative, then this would be unsolvable. Okay, so can I make this negative? Let's expand that out. Oops, 20k. Okay, they cancel out, interesting. Minus 8k, is this a 0? Okay, so k equals 0 or k equals 8, apparently they're impossible. That's quite interesting, isn't it? Oh wait, it's not that they're equal to, it's less than. Okay, so let me think. 0 and 8. So anything between 0 and 8 is impossible, apparently. That's quite interesting, isn't it?